Have you ever wondered if black holes could be made of dark matter? In the vast expanse of the cosmos, the universe holds an abundance of secrets waiting patiently to be revealed. Among these mysteries, black holes stand as one of the most intriguing. Born from the remnants of massive stars, these astronomical entities are so dense and possess such immense gravitational pull that nothing, not even light, can escape their clutches. Black holes are the universe's ultimate enigma, a space-time anomaly where the laws of physics seem to crumble. They are unseen, yet their presence is felt throughout the universe. Their immense gravity shapes the cosmic landscape, guiding the dance of galaxies and bending the path of stars. But the universe doesn't stop there in its capacity to bewilder. There's another enigma lurking in the cosmic shadows: dark matter. This elusive substance is invisible, yet its gravitational influence is paramount. It binds galaxies together, and without it, the cosmic tapestry we see would unravel. Dark matter doesn't interact with light or any known type of electromagnetic radiation, making it incredibly difficult to detect. Yet, we know it's there. It's like the universe's phantom, unseen but omnipresent, making up about 85% of the matter in the cosmos. Now, let's take a moment to consider this. We have black holes, these enigmatic entities with an insatiable gravitational appetite, and dark matter, an invisible substance whose gravitational influence is fundamental to the universe's structure. Both are unseen, both are mysterious, and both hold keys to understanding the nature of our universe. So what if these two cosmic conundrums are connected? What if black holes, these voracious gravitational monsters, are composed of this elusive, invisible dark matter? It's a question that has stirred the minds of scientists and space enthusiasts alike. Now imagine if these two cosmic enigmas could be one and the same. Black holes, the universe's ultimate devourers. But what exactly are they? These mysterious entities are, in essence, regions of space-time exhibiting gravitational acceleration so strong that nothing, not even particles or electromagnetic radiation like light, can escape from it. So how do these cosmic giants come to be? Their formation is the result of the death of massive stars. When such a star has exhausted the nuclear fuel in its core, it collapses under its own weight, resulting in a supernova explosion. After this violent event, what remains is a core so dense that it warps the fabric of space-time around it, creating a black hole. The structure of a black hole is as intriguing as its inception. At the heart of a black hole is the singularity, a point of infinite density where our understanding of physics breaks down. Surrounding the singularity is the event horizon, a boundary beyond which nothing can escape the black hole's gravitational pull. This is why black holes appear black. They absorb all light that ventures too close. Their gravitational pull is so immense that it can bend light and warp time. If you were to approach a black hole, you would find that time slows down, a phenomenon known as time dilation. It's a bit like the ultimate magic trick performed on a cosmic stage. But black holes are not just cosmic oddities. They play a vital role in the universe. They help in the formation of galaxies and are believed to reside at the center of most, if not all, galaxies. They're also sources of some of the most energetic particles in the universe, known as cosmic rays. These celestial objects are not just fascinating, they hold secrets to the universe's past and future. They challenge our understanding of the fundamental laws of the universe, pushing us to rethink our theories and explore new frontiers in our quest to unlock the mysteries of the cosmos. Dark matter, a substance we can't see, yet it shapes our universe. But what do we really know about it? Picture a cosmic entity so elusive that despite its profound impact on the universe, it remains invisible to our eyes and instruments. This is dark matter, a hypothetical form of matter that does not interact with the electromagnetic spectrum, making it hard to detect. Yet it is this very substance that is believed to make up about 85% of the universe's matter. The concept of dark matter emerged in the early 20th century when astronomers noticed something peculiar. The stars at the edges of galaxies were moving much faster than they should have been, given the amount of visible matter present. This led to the hypothesis of an unseen mass, coined as dark matter, responsible for this unexpected motion. Dark matter is not just an abstract concept studied by scientists in labs. It is a fundamental part of our universe, playing an essential role in its structure. Its immense gravitational pull is what holds galaxies together, preventing them from scattering into the vastness of space. Without dark matter, the universe as we know it would simply not exist. Despite its invisible nature, dark matter has a significant influence on the universe. It shapes the large-scale structures of the universe, like galaxy clusters and superclusters. Its gravitational effects can even distort the appearance of distant galaxies, an effect known as gravitational lensing. But here's the twist. For all its importance, we know surprisingly little about dark matter. We've yet to confirm what it's made of or how it interacts with regular matter. It's like a cosmic ghost, known only by the effects it has on its surroundings. Though unseen, dark matter's influence is undeniable, making it one of the universe's greatest enigmas. It's a puzzle that scientists are tirelessly trying to solve, a key that could unlock the door to understanding the very fabric of our universe. Could it be possible that black holes are made of dark matter? This question has puzzled astronomers and physicists for years, sparking a flurry of theories and debates. Let's delve into the cosmic connection that might exist between these two enigmatic entities of the universe. When you think about black holes, you might imagine a region of space-time exhibiting gravitational acceleration so strong that nothing, not even particles or electromagnetic radiation such as light, can escape from it. Dark matter, on the other hand, is a hypothetical form of matter that is thought to account for approximately 85% of the matter in the universe. It's invisible to our telescopes, but we can infer its presence by observing its gravitational effects on visible matter. Now, imagine if these two cosmic mysteries were intertwined. Some scientists propose that black holes could be made up of dark matter. This idea stems from the observation that both black holes and dark matter interact with the universe primarily through gravity. One theory suggests that in the early universe, dense regions of dark matter could have collapsed into dark matter stars. Over time, these stars could have collapsed further, forming black holes composed entirely of dark matter. Yet this theory is not without its critics. Other scientists argue that if black holes were made of dark matter, we would see different effects on the distribution of galaxies and stars in the universe. They believe that black holes are instead the result of collapsed baryonic matter, the kind of matter that makes up stars, planets, and us. The debate rages on, with ongoing research trying to unravel this cosmic conundrum. Particle physicists are conducting experiments to detect dark matter particles, while astronomers observe the universe's black holes, looking for clues that might reveal their true nature. So, could black holes be made of dark matter? It's a tantalizing idea, one that could reshape our understanding of the universe and its mysteries. But for now, the truth remains shrouded in cosmic mystery. As we gaze into the cosmos, our quest for understanding continues. The future of cosmic exploration is a fascinating realm, a journey into the unknown that's ripe with potential for discovery and innovation. As we move forward, technology will play a pivotal role in this grand adventure. In the coming years, new spacecraft, telescopes, and tools will be developed, each more advanced than the last. These will allow us to peer deeper into the universe, observing phenomena that are currently beyond our reach. We'll be able to probe the mysteries of black holes more intensely, and perhaps even gain new insights into the enigmatic dark matter. Our understanding of black holes, these cosmic monsters that devour light and time, is still in its infancy. Yet with every passing year, we are learning more. Advanced simulations and observations are helping us piece together their intricate nature, their role in the cosmos, and their connection to dark matter. As our technology evolves, so will our understanding of these celestial phenomena. Dark matter, that elusive substance that makes up about 85% of the universe's mass, remains one of the greatest mysteries. Despite its invisibility and intangibility, its gravitational effects are undeniable. As our tools for exploration improve, we might just be able to catch a glimpse of this cosmic ghost, to finally comprehend its nature and its role in the grand tapestry of the universe. The future of cosmic exploration is not just about technology. It's about human curiosity and perseverance. It's about our inherent need to explore, to learn, to understand. It's about pushing boundaries and venturing into uncharted territories. It's about asking questions and seeking answers, no matter how elusive they may be. So, as we continue to venture forth to probe the cosmos and its many mysteries, we do so with a sense of awe and anticipation. As we journey deeper into the cosmos, who knows what incredible discoveries await?